Okay, welcome everyone. Okay, we'll try to finish by 1 hour. Okay, already 11:07 because today is the first class. Actually, I wanted to start 10 o'clock, but I had something. Okay, so then I said, okay, better we start 11. Then I again moved to 11:30. Okay, so this is the lab. So I think we start because first time sometimes first week we don't do anything, but as it is online. So I have chosen something that is a good for online, as I will record it and you can practice again and again. Okay, and this is very useful, actually very useful, because when it would be recording, I think you can practice better way. Right? Okay, so this is your lab topics. Okay, you have 10 items. So your lab is actually 20 marks. All right. So I believe all of you know how you conduct the lab. So usually after completing the lab, you have to prepare a report. Okay. But this lab is a combination of some practical, also some analysis. Okay. Some analysis. Okay. Some of the things I will not do for practical. Okay. It is a combination actually. It is a combination. All right. So this is the 10 items. Have you studied soil engineering before or last semester? I I believe we have studied it. Soil.
Last semester.
Okay, so this is very good. So this is a same topic. Okay, you have studied soil moisture, is it? How to determine the soil moisture, right? Yeah, done that one. Okay, just let me change to which we have. Okay, why when I change this one, I cannot change. I cannot see on my iPad. All right. So I think it is very good for me. I don't need to explain too much. Okay. But anyway, soil engineering is a basic subject. Basic means you can say something is called fundamental subject. So that subject actually we need that knowledge to study other subject. Okay, like hydrology, hydraulics, even other subject, irrigation engineering. So that knowledge will be useful to connect with other subject. Okay. So one of this here you can see here, volumetric soil moisture content. Okay. I think you have studied the two approaches or maybe more than two approaches in your during your lab. Okay. So here is a volumetric. Okay. So I will explain why volumetric soil moisture is important. Okay. And then we have a rainfall, we have evaporation, then automatic mini weather station. Okay. Evapotranspiration, infiltration, stream flow. Then this is a groundwater, then watershed. Actually, this is all of this actually hydrologic cycle, components of hydrologic cycle. Okay, components of hydrologic cycle. All right. Okay, so this is your lab one. I will explain, but you, Mr. Hafiz, will show the some device once you come back. Okay, it would be easier for you. Okay, maybe one lab you can finish 2 or 3 items. Okay, I will explain the theory. What is this? So volumetric, you have a two type uh, usually. One is oh sorry. Just a minute. I think I need to change the pen. Okay. Wait, moving. Okay. Something goes wrong. Okay. All right. Sometimes okay, sorry for this. So you have studied I believe you have studied two. One is the weight basis. Okay. Wait. Another is the volumetric. Okay. Volumetric. So weight basis that you have done, I just simply explain. Weight basis, you have a collected soil from the outside, and then you have taken the weight with the enter soil, means the wet soil. Okay, that we have collected from the field, and then you put some of the soil in the small, it's called small dish, is it? You call petri dish or dish. Then you left in the oven for 24 hours. I think the temperature, maintained temperature is 105 degree or 115 degree centigrade. Okay, one day. After this, the soil usually becomes the dry. There will be no water there. Then you take the measure. So then you take the difference, and from the difference you can find the moisture content. So that process is weight basis. This one. Okay, and the volumetric is different. Weight basis means you take the things by weight, like gram, kilogram, like this. And volumetric, it is in volume, meaning that instead of gram, kg, we take the volume like centimeter cube. We take the soil as a volume, and we also measure the water also as a volume. Okay. Then we make the ratio, and the answer is the percentage. All right. So both are useful. But when you take the moisture content with two methods, the moisture content with the weight basis and moisture content and with the volumetric basis, it will not be the same. Percentage will not be the same. So sometimes the students make confuse. Just say the moisture content, percentage of moisture content. So you must know when you take the value, you must know whether your moisture content of soil is weight basis or volumetric, this one. So this is very important, okay, to make it accurate. Okay, because these two are not the same, there is some differences. Okay, so anyway, our is volumetric. Volumetric means, let's say this is the volume, this is the soil. Let's say if I take this area, sorry, let's see if I take this area, something is, maybe I write this. If we, let's say if we take this area, and okay, why this moving? Cannot move. Okay. Okay. Just I use the hand and there's some line. Okay. So what I wanted to say, let's say if I take the volume, this area, this area, okay. Let's say this is the volume, this area. Okay. So we know the volume. What is the volume? So volume means it is a B multiply A is multiply. B means this one, A means this one, and the thickness. Thickness may be the you can say BHL, okay, or length, okay, breadth, height, and L. So this is the volume. So if it is a unit is centimeter, this one, then it will be the centimeter cube. So this is the total volume. So then from here, if we can find the what is the volume of water, just volume of water, okay, volume of water, then we can determine, okay, this volume of water and this is the volume total. So meaning that moisture content is volume of water divided by volume, this one, okay. So you can determine, okay. So now we have a many techniques. You can, if you see, even you can search internet, YouTube. You just give a search volumetric soil moisture content, then you can find some YouTube. I think this is the good option now for learning. Okay, once you know the topic, that's a topic. This one, this is the topic. So this give a search volumetric soil moisture content. How to determine it? Then you will see there are many techniques. Okay, one manual technique is you collect the sample from the from soil. You collect the sample from the soil, then you put in the some glasses or somewhere, okay, then you shake it. Shake means you can do some like a blending, okay, shaking, and separate it. Once separate, then the sand, soil, or those will be deposited in the bottom, okay, and the water will be on the top, okay, water will be on the top. So after this, maybe if you put longer time after separating the water, then this water will be evaporated. But this is not accurate technique. At least you can know, okay, this is the volume of water, this is the volume of solid. Okay, this is the manual. But we have a now sensor, modern devices. So that device is very accurate. So we can use that device. Okay. So we have a volumetric moisture content, that is device, and we have a one device. I forgot the. Okay, just a minute. I can remember the name. Okay, this one is why I forget the name. Okay, okay. Anyway, I can remember this one, so you can determine. Okay, and this is the theory. Okay, so this one that you have done the weight basis. Okay, you take the sample, then you determine this using this formula. This is the weight of water, means in gram, and the solid means this is the dry soil after drying. Okay, you have put your soil in the dryer oven, then the dry soil. Okay, so that is okay. So then it is simply like this is the graphical explanation. Means you take this soil, this soil, then you put in the oven, then water will remove. You don't need to collect the water, and then you will get the solid, means soil. So when you subtract this one minus dry soil, then this is the water. So this is the water, MW, okay, and MS is this one. This is the MS, okay. So then you can find the weight basis. So this is the simple one, and then volumetric basis. So volumetric basis is this formula: volume of water and bulk volume. Bulk means your original sample. This one. So when you take the sample from the field, okay, from where? When you take the sample, normally you know how to take the sample. You use some circular core, is it? And then some uh, device, you just rotate it, and then you can collect the sample. It's called agar, is it? I think agar. The name is agar. So this one you can collect it. So this is the volume, total volume, or we call bulk volume. Bulk volume means original form, that soil you collected from the field. So that is a VB, okay, VB. And then same way, you can do the oven dry, okay, and then you can put the soil only, because water will remove. Then once water remove, this one will be, some portion will be empty, okay, after removing the water. Then you can measure the, maybe it will be here or something like this, okay. So this is the volume of soil. So if you subtract, then you can find the volume of water, okay. So this is the manual technique, okay, volume of water, right. So every system, actually we have a manual technique. Then we have a sensor, because when you develop the sensor is some electric or mechanical device, okay. Then we measure it. After this, we have to calibrate or test it whether sensor and this original one is correct, same or not. If sensor and original one is same, so meaning that your device works properly, okay. So this is a volumetric. So volumetric, so according to your lab topic, volumetric moisture content, so you have to determine like this, okay. So I think you don't need to do again in the lab, but if you like to do it, you can do, no problem. So I will give you the concept, why it is important and how you can use it in the hydrology, okay. What is the application? This application is very important, okay. Why we don't use uh, this one? This one. This one is not very important. It is important, but we don't use in hydrology, okay. We use volumetric. So if we know the weight basis theta, we call theta m, okay, theta m, this is the weight basis, we can determine volumetric basis. You can see this is the relationship, okay. So without determining theta b, he can determine theta b using theta m. Theta m means weight basis, okay. So you have to know the density of the soil, okay, b, okay, bulk density, okay. This one is the bulk density. This is the rho and this is the b. So this is the bulk density. Bulk density means you know the density is a gram per meter cube, is it? This is the unit, okay. So meaning that you take the weight and take the volume, then this, when you take this one, then you will get the density, okay. So density is measured in per meter cube or per centimeter cube, and this rho w, this one is density of water. So density of water is a pure water, it is always 1. But density of contaminated water, it will not be 1, okay. So that is the, if you see the density of water is different than 1, then you have to understand that this water is mixed with something, okay, like a juice, because juice is not a water. Juice is a mix of water plus something else. So meaning that you have some solid, okay. So when you take the density, you will not find the 1. It will be more than 1, okay. That's the thing. So anyway, so once you, so meaning that this is important, theta m. If you know theta m, then you can calculate theta b using this. But you need any additional information, density of bulk density of the soil, because we are measuring volume of water for soil. So we need a bulk density of the soil, okay. then we can determine it. Okay, and then volume we can determine like this way. This is simple. Instead of weight, we measure the volume. So you know how to measure the volume, this one. Okay, because V is what? V is pi r square H, is it? So pi r means the radius of this cylinder, inside radius or inside diameter, or you can say pi d square by 4 into H. Okay, and then H is the height of the soil column. Okay, H. So if you multiply, then you can find the volume. Then after heating, means after drying, the water will remove, then soil will, maybe some part will be empty. Then you can measure this one. Maybe this one is H1, this one is H0. Okay, so definitely this one will be less. Okay, so if you subtract this one, then you can find the volume of water, then you can. So this is the manual technique, right? So once you get the theta b, okay, so this is the theta b issue. Okay, simply you can determine either this, or if you know the theta m, using theta m, you can, if you know the bulk density of soil, then you can find the volumetric moisture content of soil. Okay, okay, why this theta b is important? Theta b is important because of this equation you can see here, this one. Okay, you can see the d here, d is the, because this is a volume, is it? This is a volume. Okay, but one of the question is here, let's say this is the soil column. So now if I ask you, let's say this is the root and this is the root. Okay, let's say from this root to this root here, let's say this is depth is, let's say I consider z. Okay, z means this one, z. If I consider z, let's say this z is 0.9 meter. Okay, this z means this distance from here to here. Okay, and then if I ask you, find the depth of water, here, from here to here, because we have a soil, we have a water, is it, from this area, because in the soil we have some water, so we know this depth. So now I am asking, please find what is the depth of water. Okay, so to answer this question, we use this formula. Okay, so depth of water means d, and L is actually this one. So maybe instead of Z, I can say L. Okay, so you can simply give the answer theta b into L. So L means this distance, this height, and theta b is the moisture content with the volumetric basis. So if you know the volumetric basis moisture content of the soil, then you just multiply by this L, so you can find the depth of water. Then you can say, okay, it is this centimeter. So now if someone asks you now, okay, sorry, if someone asks you, can you find how much water, let's say from here to here? Okay, very important questions. And when you say how much, now the question is it millimeter or is it meter cube? What? Because when you say how much, we can give the answer in 2 units. at least, either millimeter, otherwise meter cube, or maybe you can give centimeter, you can give meter. Okay, because millimeter, meter, centimeter is the same, only different, small, big, and large. Okay, and another is a volumetric. Okay, so if you want to make a volumetric, you can do the volumetric, but before volumetric, you should give the in the depth is very important. Okay, so depth means it is the d theta b into L. So this is according to this formula, we need to know theta b means volumetric moisture content. So you can determine the volumetric moisture content. Now you can do the volumetric moisture content by laboratory method, or you can use some sensor. If you give the sensor, sensor will give you instant, within a second. Sensor will give you the instant, okay, instant reading. So you can get the theta b. Also, you have a sensor for weight basis, both sensor, but volumetric moisture content is very important, okay, because we can use direct. And then if we, so you need a one sensor. We have the sensor. So by sensor we can get this value theta b, and the depth we can find from the measuring scale. Okay, then we can know direct. Let's say it is millimeter or maybe centimeter. Let's say we can say 10.1 centimeter. 10.1 centimeter means 101 millimeter. So this is the depth of water. Okay. So now we can find the volumetric volume. How much volume? So if you want to know the volume, so you know you need to know the area of this area, this one area. So if you want to calculate the area, so because this is the rectangular or square size, so you just measure this one and measure this one. So you can find the area. So area is, I just write here, area equals, let's say here is a 10, here is a, let's say 12. So 10 multiply 12. So it is 120 meter square. So this is the meter square and this is the millimeter. So this centimeter, so I can make it meter. So it is 0.1 meter. Okay. So if you will make volume of water now, so volume equals this d multiply area. D multiply area. So this is the volume. So meaning that this area we have this amount of water. Okay. So this is the, that's why the volumetric moisture content is easier and it is very applicable. Okay. But if you have but in this formula don't use theta m. Theta m means the weight basis. Weight basis. So if you use theta m, so you have to convert it. Okay. You can if you have a, let's say if you have a sensor that is a not the volumetric sensor. Okay. Right. Maybe your sensor is theta m means weight basis. So if you have this weight weight basis sensor, so you get the theta m, then you use this equation, convert to theta b, then come to here, use d. So d is the depth of water. Once you know the depth of water, then you can find volumetric. Okay. So now why it is important. Okay, I give you simple example now. Okay, let's say your area, let's say you have a, because we are agriculture engineering, we are agriculture engineering. Okay, I just give you this is I have given one diagram here just to understand. Okay, so let's say we have the area here like this. This is the area, and this area, let's say you are growing some crop, any crop. Okay, all right, and then you have some rain. let's say you have a rain. Okay, after raining, you want to measure how much water we have stored in the soil. Means, because after raining your soil will be wet, is it? Wet, it's not dry, wet. So mean the soil will hold some water. In the soil engineering subject you have studied the holding capacity, is it? Available soil water holding capacity. So soil will hold some water, right? And then how much water soil hold? So we can measure it. Okay, if you know the theta b, so meaning that you will go with your sensor, volumetric sensor, you go with this field, you use your volumetric sensor. So by volumetric sensor, there is a display here. So it display, it will give you the theta b. Okay, and then you want to measure how much water stored in my field. Let's say your field is 2.5 hectare. 2.5 hectare. So 2.5 hectare means multiply by 10,000 meter square. 1 hectare is 10,000 meter square. Okay, 1 hectare. 1 hectare equals 10,000 meters square. So if you multiply by 2.5, it is a 25,000 meter square. This is your area. This area. I'm not talking about outside. I'm talking about your field. Okay. And then let's say you are growing the crop. There is some crop. So this crop is like this. So you know this crop, the depth of the root zone. Okay. So depth of the root zone, let's say 1.2 meter. Okay. So now we multiply it to 25,000 multiplied by 1.2. Okay. Okay. So 1.2 meter. So now you can find the depth of water. So depth of water is theta b multiplied by 1.2, because 1.2 is your depth L. In this case, theta b L, is it? D equals theta b L according to the formula. So L is 1.2. So let's say your theta b is something like 0.4 multiplied by 1.2. So it can be maybe 0.48 or something. Okay. So meaning that you have 0.48. Okay. 0.48. This is, or 48%, suppose. Okay. So now how much the volume? So now you can say your area is meter square multiplied by 0.48. Okay, because here is a 12 multiply less 40%. Okay, 40% means 0.4. 0.4 multiplied 12 is 48. So it is something, there will be some amount. Okay, 1.2, how much will be this? 1.2 multiplied by, let's say let's I said 0.35, no problem. So it is 0.42. Okay, so 0.42 meter. So if you multiply by 0.42 meter, 0.42 multiply to 5,000, 25,000. So it is 10,500. Okay, 10,500 meter cube of water will be stored in your field. So can you imagine how much the price of this water? 1 meter cube, how much you buy from the water supply company for your house? Let's average 50 cent, because only 20 meter cube, until 20 meter cube is on less price. After, once you exceed 20 meter cube, the price is different. Okay, maybe this water is not nice water. Let's say price is less. Let's say 20 cent. So if you multiply by this, then you can find how much water you can save and how much money we can save, because if it is your irrigation field, you need to supply water, then you need to start your pump. So once you have a raining, you can calculate how much water you can save. Okay, from one day raining. Okay, so in that case, that's why theta b is very useful, and we can do a lot of analysis, a lot of calculation. Okay, so this is the main, but we have many other purposes. This I'm just explaining just in the aspect of agriculture. Okay? Definitely other people use their purpose. Okay, okay, this is the thing. Okay, so do you have any questions for this? Clear about or not? What is the volumetric moisture content? What is the application? Okay. Clear about this? Anyone have a questions?
No, sir.
No question? If no
No,
question,
sir.
then anything? If no question means I believe you have understood properly. So just be careful that when you use it, it's like this. So this is the purpose. So purpose is you have a theta m. Sorry. Okay. Sometimes slide doesn't move. So I think it is fine with you, but I'm my iPad. Okay, my iPad getting something. Okay, so here is a learning. Just takeaway is we have learned here what theta m. This is the weight basis, and also theta b. Okay, and then we have learned that theta b is very practical, and we use it. And theta b equals very simple formula that is what's called. If we know the theta m, then we have to use the bulk density divided by bulk density of water into theta m. So meaning that if we know the weight basis moisture content, we can convert to theta b. Once I know the theta b, why theta b is important? Because we can estimate the depth of water. Depth of water. Depth of water. Yeah, anyway, depth of water, this is theta b multiplied by L. L is the depth of soil column. So now this L can be any depth. If you know the L, then if you know the theta b and L, you can find the depth of water. So this depth of water, when you know it, because it is the one of the component, hydrologic component, because we need to know how much water in the soil. So then we can use this one, then we can know this is the amount of water stored in the soil. So then we can calculate the hydrologic cycle. Okay, because in a hydrologic cycle, you have seen the rain falls on the surface, then it entered to the soil, this is called infiltration, then it moves horizontal and vertical, this is called groundwater, and then go to the deeper. Okay, then if you like to know how much water stored in this depth, how much water stored in deep depth, how much water stored in deep depth, then we need to know the theta b first. Once we know the theta b, and then if we know the L means depth of the soil column, then we can find the depth of water. Once we know the depth of water, D, then we multiply by area. Then we can find the volume of water, total volume of water. Okay. So this way we can find the water stored in the soil. So if we know the water stored in the soil, definitely, let's say if you supply water from here, let's say 10, and this area, after calculation, you can find, okay, this is, let's say 4.5. Now you can say, okay, how much water contributed to groundwater, means deeper below this. So meaning that this 10 is entering, and here is a 4, we determine by this approach. So 10 minus 4.5 is 5.5. So 5.5 water contributed to groundwater. So this is the approach actually, okay, conceptual approach. So then we can calculate. So that's why volumetric moisture content is very important. Then you can determine with the different approach, laboratory method or sensor. Okay. So one of the one of the devices. Okay. So just a minute. I forgot the device name. Okay. For this time, because I'm thinking, that's why I cannot remember. Okay. Just a minute. Okay. Volumetric volumetric soil moisture sensor. Okay, you can see sensor. So these are the, so can you see the website now?
Yes, Lata.
Yeah, this is the some moisture content. Okay, moisture sensor. Okay, you have a different type of moisture sensor. Okay, but I'm looking the another one. This one, cavity moisture content. Okay. Yeah. Dominic. Okay. Something like this name. Oh, this one. I forgot this one. This name. TDR. Okay. Time domain reflectometer. Okay. So this is the sensor that we have in our lab. Okay. So once you put in the soil, you can see the display. Okay. Okay. You can see that here. You can see the price. Expensive. Okay. 2009 $5. So meaning that here is multiplied by 4.5 is 10,000. Okay. So we have this one in our lab. So this is expensive. That's why volumetric is expensive. And then we have some other sensor also. Okay. This is a some volumetric and some are weight basis. Okay. You can use it. Right. So YouTube is very good. You can find the YouTube, then you will see how the reading is taken. Okay. There are some people are doing the lab here. They are explaining. It is very easy. All right. Okay. So once you know this, you can do some analysis. Okay. All right. Okay. I think this one you have studied in soil engineering, available water capacity or available water holding capacity. Okay. You can find these are the formulas. Okay. I think you know about the field capacity, you know the wilting point. Have you studied this one in soil engineering or not? This term, field capacity, wilting point. Have you studied during your soil engineering course? Are you familiar with these terms? You should. I don't know what is the syllabus for this. Okay. So once you know this one, then you can determine different condition of soil moisture content. Like your case, when you eat, you feel energetic, is it? We can say I'm full. So meaning that other way you can say I'm saturated, I cannot eat. Okay, this is called saturation. But below full, when you say full means you cannot eat more. So that is called full. But below full, it is a comfortable zone. So meaning that if you like, you can still eat. Like after eating, you can eat some sweet or some dessert, whatever. Okay, so that is called your capacity. Okay, optimum capacity means comfortable, comfortable. So after comfortable, still you can eat. So this is called field capacity. So soil. Okay, and then another is called dry. Dry means minimum moisture content, where there is no water. There is a small amount of water, but that water is not available for crop. That crop will die. So meaning that when moisture content goes down, the crop will die. So this is called wilting point. Okay, so this is, I'm not explaining now. I believe you have studied in soil engineering. If you don't study, maybe I will explain later in the class. Okay. Okay. So this is the way. So now those things you can determine by this is the sensor. You can put the solar energy because it needs some energy, and then you can continue. You can take the reading. Okay. Every second, every minute, every 1 hour, you can get the reading. Okay. All right. Like IoT or whatever you can take. Then this you can prepare this graph. I think you have studied in soil engineering. You have studied soil water tension. You have used the tensiometer, or maybe otherwise it's called Newton meter, different meter. So you have determined the tensiometer, tension, soil pressure, okay, stress. So soil tension and the moisture content, when you plot together, then you can find this graph. This is called soil water release graph. Means you can see how water is released from soil. Okay, this is so different soil is different system. So that one you can develop using two sensor. One is moisture content, another is soil potential. Okay, this is on soil water potential. So soil water potential is determined using centibar, bar, kilo, Pascal. Okay, so this is very useful term. So it doesn't use in hydrology because I explained the volumetric moisture content. So that's why I just give you some additional. So meaning that if you have another sensor, then you can prepare this soil moisture graph. This is very important for irrigation purpose. Or if you want to know the crop water status, means whether this water is sufficient for crop. How is the water status in the soil? Whether it is good or bad for crop. So to analyze those, to make a decision for this graph is very important. And this graph you can develop using two sensors. One is soil moisture. So it is means volumetric. You can see here volumetric. Another is tensiometer. Okay. So once you have these two, then you can develop this. Okay. Develop this. So this is very important because you can see here theta FC. Theta FC. And another is theta WP. Okay. So meaning that in between this, from this line to this line, so this is the water, means this water is available for crop. Okay, available for crop. Like I can give you one example. Let's say this is the this is the tank, and I put here tap. Okay, put here tap, and then I ask you to fill by glass. Let's say what, then let's say this is the juice. Okay, any juice. So if you open, then you can get the juice. Is it? Am I right? So consider, let's say at the beginning, normally those serve the food, they give the level full. So I can say this is called theta FC. Okay, not they never give full on the top. That is called saturated. Means if something happened, it will drop. Okay, that's called saturated. So they put some empty. So this is this. Okay, then people are taking the juice. Then let's say juice level comes here. So now you come and you are trying to get the juice. Will you get the juice if you open this? So now the juice level is here. Means this is your tap, and now you're trying to get the juice. Will you get the juice from here now? When the level is here? Anyone? So answer is no, is it?
Yes.
Yeah. So meaning the same. Means you have some juice here on the bottom, but you cannot take it. So theta WP is same. Since theta WP is the moisture content in the soil, that water is not available for crop. Crop cannot take it. Okay. Because when crop uptake the water, crop needs some energy. So crop cannot pull this water. Crop energy is less than this water. Energy is less. Means crop will suck. Suck uh, means it is called uptake, is it? Suck. Okay. But crop that's energy is poor. Then how strong, how stick or how strongly remain this water in the soil. So meaning that it's not available for crop. Same like your juice. If you come here, open the tap, you can get the. So this is called theta W. So sorry, WP. So this water is available for crop. So that's why if we know the theta B, we can know the status. Meaning that theta B can be here, can be here, can be here. Okay. If theta B is here, then we can know this. If theta B is here, we can know this is. You can see the number is increasing. Stress is increasing 30, 100, 30, 300, 10,000, meaning that when moisture content reduces in the soil, the soil becomes dry and plant grows under stress and stress and stress. Okay, means crop faces difficulties to get the water from soil and then crop die. Okay, so everything actually we can explain by theta b. That's why theta b is very important. Not only this, also in the hydrology that I mentioned, how much water stored in the soil, then we can calculate the water balance or hydrologic cycle. All right. So this is your first lab. And now if you have any questions, please ask. Okay. So if you have a defined soil, we can know the theta C, theta WP, then you can determine this. I think you have studied this one in soil engineering subject. I don't want to discuss. Then your second lab is rainfall. Okay. Rainfall analysis. Okay. How much the rainfall? So normally we have some rain gauge. Okay. Rain gauge. So if you like to know the rain gauge, so I bring you to the website. If you go to the online, you just say the rain gauge. Okay, if you have rain gauge sensor, whatever. Okay, so this is the simple rain gauge. There is some uh, panel or cork type. Okay, now we have a sensor type that we can connect with our mobile, we can connect with our PC. Okay, we can hang it. So if any amount of rain goes, then it can measure it. Okay, so we can see the different type of rain gauge. Okay, this is easier for you. Okay, I think we have one or two types in the lab. You can see that. Okay, but this is the measurement. Okay, so measurement is one aspect, but hydrology is not just measurement of the rainfall. This is nothing. Okay, so this rainfall you can measure yourself. You can collect from your some of the department, because in Malaysia we call. Okay, so you have to know this where we can get the rainfall. Okay, because to study hydrology we need the rainfall data. Okay, So first thing is where we can get the rainfall data. One, you can do the measurement. Okay, measurement. Second is the secondary data, means recorded data. So this one is done by JPS, Jabatan, Pengaran, then Salidan. Okay, in English we call DID. So Department of Irrigation and Drainage. Okay, maybe some of your parents or your brother or sister or relative, maybe they are working here. Okay, JPS DID. This is very well known and big department under the Malaysian government. Okay, it's very big department. Okay, they have a lot of activities. Okay, so this hydrology is under this department, JPS DID. If you say hydrology, it is belongs to JPS DID. So meaning that in the JPS DID you can find the rainfall data. Okay, it is available. Okay. Okay, if you go to the website, I can show you like this, Malaysia. I think I have the link. You can see here ZPS DID, Department of Irrigation and Drainage. Okay, if you click here, okay, what happened? Is it internet is not available? Okay. Okay. Try again. So every state we have they have the. I'm not sure what happened. JPS Malaysia. Okay, you can see Department of Irrigation Drainage. This very big department. So this is the JPS where you can find all the hydrologic activities. Okay, so you can get the rainfall data from here. You can go to this website. You can see the resources. You can got many of the things. Okay, and then you can see if you like to get the data, then there is a data service here. Tender calendar online species. Okay. Where is this services? You can see service, flood, river, coastal, water, resource management, stormwater, dam, structures. So all of this actually hydrology. Okay. If you study hydrology, if you are well known, if you have a good knowledge with the hydrology, so you can do all of this thing. Okay. Yes. You can work anywhere. Flood mitigation, river management, coastal management, water resource, stormwater, dam, structures, everywhere. This is hydrology. Okay. Also hydraulics, both. Yeah. Okay, so this is a where is a data? There is a one section is called e-participation. Okay. Customer satisfaction survey. I division. Okay, so this is the division. Okay, okay, anyway, I think there is a one this online service. I think somewhere you can find. Okay, so please visit this website. Okay, then you can find there is maybe sometimes they update the website. I because previously it was a somewhere bottom where you could find the data. Okay, so data is normally for academic or university students, data is free. So from the JPS you can find all data. All right. Okay, so this is the you can find the recorded data throughout the Malaysia. Okay, there are many stations, rainfall stations, so you can okay. So if you want to see the rainfall station in Malaysia, you can give the search. So nowadays, it is easier. Okay, you can say rainfall stations GPS. Okay, or rainfall station map, rainfall station Malaysia. Okay, what you want to see? Let's say Malaysia. Okay, station info. Okay, rainfall data. So this is the rainfall data you can find here. Hydrological station. This one inventory. Okay. So now if you go by state, Johor, Bahru, Kelantan or whatever. Okay. Let's say Selangor. If you want to set district, which district you want to see. Okay. Let's see if you want to see the Sepang. Sepang is already Sepang, I believe. Okay. Whatever. Let's see. Station. If you know the station name, you can write. Let's rainfall. Then search. Then you can see the station names. Okay. Right. And then you can see the active. What is the location? Longitude, latitude. Okay. When it started in 2002, 2002. Some is before, some is new station. Okay. So you can get. So if you need a data some particular areas, so you can find the option. You can find this. You can give the search. From the search, you can find your area. Then you collect the station name. This called station name, and then you have to see how long that you need. So if you know the station, then you can see this station started in 2022. Sorry, 2022. So if you need the data from 2002 or maybe 2010, then you have to mention. Okay, so I need data from this from here. Then you can get the data. If you request data as a student, it is free. If you request data as a businessman, you have to buy it. Okay, so this is the option. Okay, so you can find it. All right. Okay. So this is the rainfall you can find. Okay. I can get the link here. Okay. All right. Okay. First thing is your okay, what is called rainfall analysis. Okay. So we will do the analysis later. Okay. First thing is calling how to get the data. You can get the data like this. Okay. Second, your third lab is evaporation. So evaporation data, it is also hydrologic component. So this evaporation data also you can get from the JPS. Same place, same data website. You have to apply. You can get the evaporation data. Okay. So evaporation data is collected using this device. So this device we have in our lab. So when you come back, you can see it. Okay. This one. This is called evaporation pan. This name. This is it is a steel circular shape. Okay. It is quite big. So this is called evaporation pan. Okay. And this one beside this one is a modern device. It is called weather station. So this weather station, this one sometimes we call automatic weather station. Okay, so this device actually collect few information. Okay, one is temperature, then relative humidity, then it's collect also wind speed, then wind direction also. Even this one, you have a channel, you can measure the soil moisture. Okay, meaning that the TDR soil moisture time domain reflectometer. This soil moisture you can put the here, then you can connect here. So all of these things you can also the rainfall. So that's why this is called automatic weather station. So all the climate or weather data you can collect at your field, meaning that this is a portable. You can move it, so you can collect real-time data from your field. Okay. So this one you can install fixed. Let's say you just install one place, then continuously you are collecting the data for 1 year, 2 years, 3 years. So that is a JPS do this. Okay, so JPS has this, but this one is not actually under JPS, but JPS also has. But this device means this temperature, relative humidity, wind speed, soil moisture, rainfall. This all of this collected by MMD. MMD is the Malaysian Meteorological Department. Okay, this M is Malaysia, M is meteorological, meteorology. Yeah, D is the department. I think in Malay it's called Kaji Chuacha, something like this. Yeah, if I'm not mistaken. Okay, so meteorological department, MMD. So this department you can find this all of this data. Okay, so this is the data collection. So rainfall, you can get the rainfall also here, but rainfall also you can get from GPS. Okay. Okay. This device we have in our lab. So when you come back, you can see it. Okay. How collect this data. So you will do the lab. Okay, this one. But my purpose is Mr. Hafiz will show you the lab. I will do the analysis. Okay, I will teach you how to do the analysis. Once you collect this data, what to do. Okay. Okay. So on Monday, I hope you can remember. On Monday, I showed you that one of the hydrologic component was evapotranspiration. Can you remember now? Evapotranspiration. Okay. So this temperature, relative humidity, wind speed, this data we need to calculate this ETC. So this ETC we can calculate using data obtained using this device. Okay. So to calculate this ETC, okay, we have a formula like this. Okay. So this ETO we can calculate using the temperature, wind speed, and the relative humidity. Also, we need another thing is location, like latitude, okay, and also elevation. Okay, so latitude, elevation you can find using GPS, and this device will collect temperature, wind speed, elevation. So once you get it, you can calculate the ETO. Once you get the ETO, you can calculate the ETC. So this ETC is a component of hydrologic cycle. All right. All right. So this is your lab 4. So we have finished 4 labs today. All right. So when you come back, you just see the device one day. Finish 4 labs. Okay. My purpose is I will explain the theory. I will explain the application. Okay, and the analysis. Okay. So this is the ET how it comes. Okay. ET is the driver that determines how much water is being used by plant, or maybe how much water is used by plant in the hydrologic cycle. Okay. So that ET is this one. It is C. When it's write C, it means it is evapotranspiration for crop. It is equal to Kc multiplied by ETO. Kc is the crop coefficient. Okay. This is the Kc is the factor actually, because when crop grows bigger and bigger and bigger, so crop water demand increases. So that factor is determined by Kc, crop coefficient, and ETO it comes from the climate or weather station. So this is mainly this. If you collect the data from MMD. So now if I ask you how to get the ETO, so your answer is you contact the MMD, collect the data, temperature, relative humidity, wind speed, lat means latitude, and the elevation. So meaning that any area, let's say you want to know what is the ET here, this place. So this place means you have a latitude, you have elevation, you can know it. And then you check whether you have a station at MMD. MMD you have, if not station here, near a station. What is this? So from the nearest station, you collect this data. Once you get this data, then you can calculate the ETO. And Kc is the constant, then you can find this is the answer. So clear now? I just
Yes, sir.
I just explained briefly, but in the class I will explain a little bit more, because this one today I am explaining just for your lab practical purpose. Okay. So anyway, we have a two technique to determine ETC. One is evaporation. Evaporation means that pan that I showed you before. So when you say pan, it is ETO equals EP multiplied by Kp. So this EP evaporation comes from this pan. So when you measure evaporation from this pan, you can multiply by Kp. Kp is a constant. It is a 0.75. Value is 0.75. Okay. You can find the ETO. So then you can put it here, ETO. ETO multiplied by Kc is the same. You can see here, ETC equals ETO multiplied by Kc. ETC equals ETO multiplied by Kc. But when you use pan evaporation, you don't need the temperature, you don't need the relative humidity. You just need the pan evaporation. The depth of water means how much water lost from this pan. But when you use this technique, how is called this is called pan evaporation method, and this technique is called Penman-Montic model. So this one is experimental, and this one is empirical or mathematical. Okay, so it is a mathematical equation, is a complex equation, but we needed those data that I just now wrote here: temperature, relative humidity, wind speed, latitude, and elevation. Once you have this 1, 2, 3, 4, 5 data, then you can calculate this. Once you calculate the ETU, then you can find this ETC. So Kc value is a given. You can see here, this graph you can find. Okay, so I will explain more during the class. Yeah, let me finish. Okay, so this is the, just I separate in two slides. Okay, so this model is called Penman-Montic method. Okay. 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 Last, I want to explain another thing is maybe just simply I will explain you, so you will practice. Okay, before this. So this is called NASA powered deep data access viewer. Okay. Hopefully I can finish by 10 minutes before one. Let me try. Okay. So this is the link. This is a free. So otherwise, you can just give a search NASA Power DApp. If you give a search, you can find the website. Okay, like this one. Okay, so I have given the link here. So once I click it, you can see the website. Is it now?
Yes, doctor.
Okay, very good. Now you can see how good this is. Now you can see the left side. If you cannot find this one, sometimes there will be some icon here. Maybe you can click it like collapse. You can see here collapse. Then it will disappear. Okay, then you can click again. Then it will show. Okay, means here is showing just symbol. You cannot see the writing, but if you click here, down bottom is called, you can see the single point. Okay, because this website is purpose is to collect the data, because for our education purpose we don't need to go GPS, we don't need to go MMD, we can collect data from here. Okay, that's why I said okay, click on single point. Okay, please remember the step, because I'm recording now, you can practice again. Single point. Then you can see the community. You can see here community. Community means users. So what is this? Here. Community means user. What is your purpose? Renewable energy. Do you study renewable energy? No. Sustainable building, meaning that city areas? No. We study what? Agroclimatology. Am I right? So you can click this one. Select agroclimatology. All right. Then temporal level. Temporal level means time. Do you want hourly, daily, monthly? What? So I want, let's say, daily. All right, choose daily. Otherwise, we can choose monthly and annual. We don't need hourly. Okay, all right. So we have chosen the community, then we have chosen the daily. Okay, then next one is what? Location. Okay, so temporal level is this location. Location is a latitude and longitude. So if you know your latitude, longitude, let's say last time before this, I showed you here. This is the station name, is it? You can see the latitude, longitude here from the station. If you know the some station, what is the station name, what is the longitude, latitude, then you can copy and paste there. Let's say this one. Okay, you can copy. Okay, you can bring here. Okay, then longitude. Okay, you can bring here. It should be in the decimal like this. Okay, once you put it here, then you can see the Malaysian map will display here. Oh, sorry. Only I I click on the wrong place. So just you put the enter. Once you put enter, you can see the ball. It comes in Malaysia. This is the location. Okay, you can. This is the location here. This place. Okay, this is the one way you can put the longitude, latitude. Otherwise, you can put the you can browse the map. You can browse the map and you can find where is it. Okay, let's say you want to find the EPM. Okay, what is EPM? So you can find EPM. This is Subangja, somewhere is this side, Sikamangan. Okay, University Putra, Malaysia. Okay, so here. Okay, so you can click. If you click here, then you can see a longitude, latitude will change. You see, changes. So meaning that this location is this latitude. Okay, so now you choose the community, you choose the time, you choose this. Now choose the how long data you need. Okay, so this data is available, I think, from 1982. Okay, so you can choose 1982. Let's say I choose 1983. Okay, 1983. Let's say from January, 1st January. Okay. So this is 1983, because 1983, 1st January. Then what is the last? Last maybe you can choose, let's say 2024. Okay, and maybe it is January, it is December. Okay, I'm not sure it is available. 2024 is available or not, but 2023 is available. Okay, because they possess some data, so better I keep 2023. Okay, it's easier. Okay, December. Where is the 31? 30. Okay, 31. Okay, so our data is 1983 to the 3. So this is the duration data. So now parameters, what parameters you want? Okay, so now you can see here parameters. You have is clear sky, those you can see here. This is the temperature. Okay, so for our agriculture purpose, we have to calculate the temperature at 2 meters height, 2 meters, always 2 meters. So we need a few things. We need a temperature at 2 meters. So this temperature is 2 meter means average. But we need a maximum temperature. This one maximum. Then we need a minimum. If you want the average, also you can collect from here, or you can calculate average. No problem. Okay. If you want to, let's say, also you want to take the average, so you can collect from here like this. One more thing I tell you. You see, I selected this one first. I selected maximum temperature, then minimum temperature, then this one. So when you download the data. So data will come this sequence. If you click first temperature, this one first, so this one will come first. Okay, so that's why sequence, you must follow the sequence. Okay, if you don't want this, you just click it. Don't want. Okay, but first maximum temperature, minimum temperature. Okay, if you want average, okay, no problem. I get the average. No, it's, then humidity means relative humidity and the rainfall. Here you can see here humidity and rainfall, precipitation. So you choose the rainfall first. Sorry, you choose the relative humidity first. You can see 2 meters. So this one. Okay. After this, we need the wind speed. So you choose the wind speed. After this, relative humidity, then wind speed. Wind speed at 2 meters. Okay. No need maximum, no need minimum, just average. But temperature, we need maximum and minimum. Okay. Temperature, we need maximum, minimum. Relative humidity, we need the average. Wind speed, we need the average. And this rainfall. So rainfall, choose at the last. Okay. Then choose the rainfall. So our data selection is done. You can see here temperature, maximum, minimum, relative humidity, wind speed, and you can see our data will come this sequence that I clicked. Okay, based on my click. Okay, so then now it's done. If you want to make a soil moisture content or those, I think we don't need this one. Okay, all right. So rest is what is the data type format. What format you want? We have a different format. So here we need this CSV. CSV actually this is the Excel format. Okay, Excel format. So thing is done. Just submit. Once I submit, the data is down. Data is now downloading. Okay? So this thing is you must practice. Okay, you have to learn how to download this data because after this I will give you the assignment. So you have to download the data, then you have to do the calculation. Okay, next class. Okay, so now I save this data. Okay, let's say I put in this folder. Okay, so my data is saved. Now I can show you how is the data. Okay, because our data is here. This one power. This is the power view data. Okay, just this is the Excel data you can see. Can you see this Excel now? Can see the Excel?
Yes.
You can see the sequence that I followed. Tmax, Tmin,
Yes.
average, relative humidity, wind speed, then rainfall. Okay, so data comes in this sequence, and you can see the data. This is the year, this is the day of the year. It doesn't give the date. It comes like this. 1, 2, 3. Let's say this one we have 100, 365 days, all 1983. Okay, and this is the data. Okay? Until 2023. You can see last one is 365, means it is available. Okay, so this is the data. So once we have this data, then we can do the analysis. We can calculate the ETO, we can calculate the rainfall. Okay, all right. So this is the data is available. So I will share you this data by WhatsApp. Okay, but you have to download. I will share the recorded video. Then you can download how to do it. Okay, I have finished almost. No more. I think I have one more slide left. Okay, so once we get this data from this website, we will do this analysis, evapotranspiration and rainfall. So evapotranspiration and rainfall analysis, we have to use this formula. Okay, I will give you my handwritten calculation. Okay, this formula, this. Okay, then you can please practice yourself. Okay, what I have, what I have, what I will give you, just look it step by step. Okay, whether you can follow or not. Okay, something like this. I just show you here. whether it, I finished my lecture finished. Just I show you this file. Okay, where is this? Okay, sorry. Here, hydrology. Okay, resources. This one. Can you see this writing? My writing.
Yes, doctor.
Yeah. This one I wrote this my stylus on the iPad. So you can see this maximum temperature, minimum temperature, relative humidity, wind speed, then latitude and elevation. So using that, I use this. That is the formula that I showed you on the slide. Then you have to go for calculation. Okay. How many pages? Can you see? 10 pages. This is the long calculation. Okay. So after this, you can find the ETO. You can see here 4.159. Okay. So this one just I will share with you. I'll share with you. Just look it. Okay. This one I cannot show in the class. It's difficult. It's very long. Okay. So all of you, it is very easy. You have to just follow step by step. Now, hold on. Okay. So this one I will give you by advance. Okay. Then we'll go do the rainfall analysis. Okay. So that is your lab 5 next week. Lab 5 next week. I will explain ETO calculation that just now I showed you my handwritten and the rainfall analysis, because the rainfall data we have already downloaded from this website. So now with this data we will do some analysis, and by the analysis what to do. So this is I have shown the data purpose. So this data we need it to study the hydrology. Actually those I showed the hydrologic balance or hydrologic cycle. Okay, so rest will be analysis, and Mr. Hafiz will show you the some lab devices, how to collect this data, how to get the rainfall, how to get the temperature. Mr. Hafiz will do that. I am not good in this device. Okay, I'll show you the analysis. All right. Okay, but last but not least, this is something I show you. Maybe if you like it. So once you have a expertise in hydrology, you can develop something like this. Can you imagine what is this? This one is not your level, but once you finish, then you can do the master's or PhD. You can do this kind of analysis. This is called flood simulation. When rain comes, heavy rain, so how the flood comes, and this one is flood is going, water is going. Okay, this is at the normal condition, and you can see the water depth. Water depth means when it is red, the water depth is high. Okay, this one is less. So when heavy rain comes, you can see this area is expand. When area expand, the water depth also expand. You can see.
Doctor,
Yeah,
excuse me, doctor. We have another class at
yeah,
1.
I have finished. So you can
Yeah.
leave now.
All right.
Okay, so
Thank you.
this one I will share with you. This slide, this recorded slide. Okay. Yeah, I have done. Okay, thank you. So you can join the class. Okay.
All right. Thank you, doctor.
Okay, welcome.
Thank you, doctor.
Okay, thanks.